My name's Alison and I'm the Executive Director of USYD Rocketry Team. We're here today at the University of Sydney in Australia. Before we begin, I would like to start by acknowledging the traditional owners of the land on which the University of Sydney campuses stand, the Gadigal people of the Eora Nation. I would also like to pay my respect to elders past, present and emerging. At USYD Rocketry Team, we have a proud history of being the first university-based rocketry team in Australia. We formed in mid-2016 and 3 years later we were the first Australian team to enter Spaceport America Cup. In 2019 we headed off to New Mexico with our rocket Silvereye and we took out first place in the 10,000 foot COTS category. We're excited to continue that journey today by entering the 30,000 foot COTS category at Spaceport America Cup 2021 with our first ever 30,000 foot rocket Firetail. While the project started in 2019, manufacturing is not yet complete due to COVID-19 complications. Firetail is slated for completion next month and we look forward to launching in the near future.
As Alison mentioned, Firetail is USYD Rocketry Team's first entry into the 30,000 feet category of Spaceport America Cup. Despite many setbacks due to COVID-19, our rocket is now mostly manufactured and we plan on test launching in the next couple of months. Firetail flies on a Cessaroni 03400 rocket motor, the highest impulse 98mm motor readily available in Australia. Firetail has a wet mass of 73 pounds, a length of 10 feet, and diameter of 5.5 inches to accommodate a 2U CubeSat payload. Our rocket has dual parachute recovery and dual redundant avionics systems.
Firetail employs a dual separation, dual deployment recovery configuration to conform to the IREC testing and design requirements. This means that our main parachute and our drogue parachute are located in separate compartments to increase system reliability by eliminating the chance of tangling between the two systems. Drogue deployment occurs at apogee so that we can prevent the ballistic descent of our rocket and to also ensure that the descent speed is one at which the main parachute can deploy safely.
Our avionics system fulfills three main purposes: initiating recovery events, tracking Firetail, and providing flight data for simulation. As per the IREC rules, we implement independent and redundant systems in our flight computers, power supplies, electric initiators, and energetics. For energetics in particular, we require 2 stages to arm.
Firetail's payload is an experimentation platform designed for the testing and validation of satellite attitude control systems. The payload consists of a pico satellite suspended in a gyroscopic rig, which is in turn housed in a launch vehicle integration structure. The combination of gyroscopic rig and quasi-microgravity experienced near apogee will subject the pico satellite to a dynamic environment mimicking that of space. This will allow the attitude control system to control the pico satellite's orientation and perform a detumbling maneuver.
The role of the flight analysis subsection is to accurately model and simulate the flight trajectory of Firetail to ensure it can reach 30,000 feet as closely as possible. What this requires is extensive and detailed modeling of the launch vehicle so we have every aspect of flight trajectory as accurate as possible.
As Alison previously mentioned, working in a global pandemic has come with its own unique issues and challenges which the team has had to overcome. Not least of which has been that many of our members graduating before the project has been completed. To help with this, we've strengthened our own knowledge transfer procedures through the help of our sponsors and academics. This has been completed through workshops and practical learning experiences for our members.
Before we finish up, I would like to say some thank yous. First of all, a huge thank you to the University of Sydney and the Chancellor's Committee for their ongoing support. I would also like to say a personal thank you to Professor Stephen Williams, Associate Professor Matthew Cleary, and our mentor, Mr. Stuart Campbell.